The topic today is endothermic and exothermic reaction. But before we continue, let's look at one of the evidence of chemical reaction, which is changing temperature. When there's change in temperature, you're talking about change in energy, okay? Either the temperature is increased or temperature is decreased during chemical reaction. What does that mean? That brings us to the part of chemistry called thermochemistry, which is a branch of chemistry that deals with interrelation of heat with chemical reaction or physical change of state. So thermochemical changes are often described in terms of system and surroundings. Okay, let's look at that. In order to better understand the energy changes taking place during a chemical reaction, there are two parts we must define. Two parts of the universe called the system and the surroundings. The system, as shown in this image below, the system is physical or chemical processes that are being monitored during experiment or during observation. You're doing experiments in the lab. That thing you're interested in is your system. What you're monitoring, what you're observing is your system. Every other thing around it is the surroundings, okay? Everything around it is the surroundings. Can be water, it can be air, it can be packaging, etc. So if during a chemical reaction, the energy is being given off from the system to the surroundings, is called exothermic reaction. From the system to the surroundings. And if the energy is going from the surrounding into the system, we call it endothermic. So during exothermic, heat is released by the system, okay, to the surroundings. During endothermic, heat is absorbed from the surrounding to the system. So let's look at this some more. This is called change in enthalpy. Delta H is called change in enthalpy. Okay. When the change in enthalpy, when reaction is carried out under normal conditions, change in enthalpy is equal to quantity of heat. Okay. So I want you to have an idea what this means. So in this left image, in this chemical reaction or physical change, what is happening here? Energy is absorbed by the system. You see, from the surrounding, energy is being absorbed into the system. Energy is absorbed by the system from the surroundings. So the system gains heat from the surroundings. So the temperature of the surrounding will decrease. So surroundings gets cooler. But on the right image, which is exothermic, the energy is released by the system into the surroundings. And as such, temperature of the surrounding will increase. So, and because the temperature of the surrounding will increase, the temperature of the system will decrease. So quantity of heat will be negative. But here, quantity of heat will be positive. Okay? So let's look at an example. Ice, we've experienced ice. In everyday life, we use ice all the time. Why does the ice melt? It melts because it absorbs heat from the surrounding. The ice is the system. The heat is absorbed by the system. The heat is coming from the surrounding. So the surrounding will be cooler. Then when the heat is absorbed by the ice, it melts. Then when something is burning, heat is released to the surroundings. Like you're sitting near the fireplace. Heat is released to the surroundings. So the surrounding will get hotter or be warmer because it's released to the surroundings. Okay, and that's exothermic. Okay, now this is a representation of what is happening during endothermic reaction and exothermic reaction. So this is potential energy diagram. Here we see this is reactant. This is showing energy of the reactant. This is showing energy of the product. What is happening here? Energy of the reactant is less than energy of the product. In other words, energy of the product is more. Why? Because during endothermic reaction, heat is absorbed. Because energy is absorbed, then the energy of the product is more than energy of the reactant. But during exothermic reaction, the reactant has more energy than the energy of the product. Why? Because here, energy is released. When energy is released, the product will have less energy. We can look at this how it's shown in equation. If something is exothermic reaction, you see, heat is part of the product. Okay, heat is released, is part of the product. But if something is endothermic, heat is part of the reactant. Heat is absorbed. Heat is absorbed. Okay? Let's look at more examples of exothermic process as it in everyday life. Remember, exothermic process describes a process that produces heat or gives off heat to its surroundings. We have to know that first. Now, if we have a hand warmer is an example of an exothermic process because hand warmer is warm, okay? The heat is released from the hand warmer into its surroundings, okay? So heat flows from the hand warmer to the surroundings, which is like a hand. The hand is the surrounding. Heat flows from hand warmer to a hand. So that's exothermic, okay? Let's look at endothermic, okay? Now, if we have a cold pack in our hand, cold pack, the heat will go from the surrounding to our hand. Okay, your hand becomes the surrounding if you are holding a cold pack. The heat enters the cold pack from your hands. Your hands has a low temperature during the endothermic process. So this is practical. This is what we experience every day. Okay, again, endothermic process describes a process that takes in, absorbs energy from its surroundings. The cold pack, your hand is the surrounding, is warmer, so heat is flowing from your hand to the cold pack. Okay? That's endothermic. Okay? I hope it makes sense. Let's look at simulation showing exothermic reaction. Okay? Here we go. And then I think before we continue, let's refresh our memory as to what happens during chemical reaction. Remember, during chemical reaction, bonds are broken and new bonds are formed. Bonds of the reactants will be broken. And then the atoms will rearrange to form a new product, which is a new substance. That's what happens during every chemical reaction. Bonds are broken, new bonds are formed. And chemical reaction is as a result of rearrangement of atoms. Now, let's see this in action. I want you to take note of this. Take note of what is happening here. Okay. Exothermic. you see more energy released than the energy going in. More energy released. Okay? Exothermic. So let's look at it again. You break the bonds, make new bonds. There's rearrangement. Overall reaction. Energy is released. That's why you see more here. Look at here. Because this reactants has more energy, it doesn't need to absorb a lot of energy for the reaction to take place. But because energy is released, that's why the product has less energy than the energy of the reactant. Okay, let's look at endothermic. Okay, look at what happened here. As we saw, energy of the product here is more. For this to take place, you see, it needs a lot of energy. Energy is absorbed. Look at that. We got overall reaction. Okay. So this simulation, let's look at it again. It's telling us what is actually happening during chemical reaction and the change in energy. Let's watch a little video. This will help to enhance what you've learned so far. Students learn differently, so I like to use different methods.
Your reaction shows that you are happy to learn about reactions. Let's learn more about reactions. Do you know about endothermic and exothermic reactions? First, remember the meaning of exo and endo. Exo means release and endo means absorb. And do you know about thermic? It means heat. So endothermic reactions are those which absorb heat, and heat is released in exothermic reactions. Okay, can you give me an example of an exothermic reaction? Oh yes, you are right. Burning of matchstick gives out heat. It is an exothermic reaction. Now, can you give an example of an endothermic reaction? Wow, you are right again. Evaporation is happening as heat is being absorbed by water and molecules are getting away from each other. Look at this picture. This picture is a photosynthesis process in plants. Can you tell which reaction this is? You have understood it well. Photosynthesis is an endothermic process as plants take heat energy from sun and convert them into glucose with the help of water and carbon dioxide. Exo and endo. Exo means release and endo means absorb. And do you know about thermic? It means heat. So endothermic reactions are those which absorb heat and heat is released in exothermic reactions.
Okay, I would like you to do these practice questions. Which one is exothermic? Which one is endothermic? Pause the video and do it. Pause the video.
CNN national politics correspondent Eva McCann. Jeff, how important is it?
How did you do?
Kamala Harris to sort of
If you see yourself not getting it right, it means you didn't understand the concept. You have to go back and watch the video. I also want you to do this challenging question. This challenging question is what will determine if you really, really understood it. Okay? I hope this video helps. Thanks for watching.
Much more forcefully